In this video, I'm going to explain how you want to think about linear equations so that you actually understand what's going on. So this isn't about memorizing steps. This is about actually understanding how linear equations work. And the trick to understanding how linear equations work is a balanced scale. So I want you to think about a balanced scale. I'll show you a picture. So here we have a scale, two plates, a plate on the left-hand side, a plate on the right-hand side. And in each plate, there's a marble. One black marble on each side that weighs the same, so the scale is balanced. Here's a question. How can I add a small red marble to the right-hand side of the plate and stay balanced? So I want to put this marble here, but I want to stay balanced. Do you know how I'm going to do that? I'm going to add a small red marble to the left-hand side. See, I can add a red marble to the right-hand side and stay balanced if I add a marble to the left-hand side. See, now I've added a red marble to the right-hand side, I've added a red marble to the left-hand side, and I'm still balanced. This, honestly, is the trick to linear equations. You know what linear equations are. If I were to write 5 equals 6, you would, obviously this isn't true. Okay, so you do have a sense of what an algebraic equation is, or a mathematical equation is. So let's look at something like 5 equals 5. And notice how I'm going to exploit this idea that when you have a balanced scale, you can add marbles to both sides and stay balanced. So the question I'm going to ask is, if I have 5 equals 5, can I add 1 to the right-hand side here? Well, think of the balanced scale. I can add 1 to the right-hand side as long as I add 1 to the left-hand side. See, do I stay balanced if I do this? Let's add a 1 to both sides and see if we stay balanced. So on the right-hand side, I add a 1. On the left-hand side, I add a 1. And what do I end up with? 6 equals 6. Okay, and it's not just adding. Consider, let's say, okay, I have 6 equals 6. What if I decide that I want to divide the left-hand side by 2? That's legal, as long as I divide the right-hand side by 2. I end up with 3 equals 3. See, I'm still balanced. Think of the balanced scale. I can do whatever I want to one side of the scale as long as I do it to the other side of the scale. I can add marbles, I can take out marbles, as long as I'm even about it. I stay balanced, I stay equal. Okay, so we have 3. Notice I can decide to square. If I have 3 equals 3, I can decide to square both sides. And I end up with 9 on the left, I end up with 9 on the right. So this is the moral of the story. Given a mathematical equation, I can do whatever I want as long as I do it to both sides. Now, you might be thinking that that's neat and everything. Okay, you can think about equations as moving marbles around on a balanced scale. But how does this help us solve equations? Well, here's how it helps us solve equations. When you're solving a linear equation, this is what you really want to get to. You want to get to x equals, right? You want to know what x equals. Moving marbles around is how we're going to get to this place of x equals. Let's look at a linear equation. 2x minus 7 equals negative 3. Now, my goal is to get x all by itself. Anytime you're trying to solve a linear equation, you're just trying to get x all by itself. I want to have x equals all by itself. So really what I want to do, really what I want to do is I have to get rid of the negative 7. See, there's a negative 7 attached to my x. And I want to get rid of the 2 being multiplied to x. See, I want to get x all by itself. But I have this minus 7 attached to it and this 2 being multiplied to my x. So, I want to get x by itself. How do I make the minus 7 disappear from the left-hand side? Well, I can't just erase it. Okay, that's cheating. But what I can do is move marbles around. So I have 2x minus 7 on the left-hand side. I want you to think, what's the opposite of subtraction? What's the opposite of subtraction? Addition. So if I want to make a minus 7 disappear, I can just add away that minus 7. This is what I mean. I have 2x minus 7 equals negative 3, right? I want to get x all by itself. So I want to get rid of this minus 7. I can make a minus 7 disappear by adding 7. Now this might seem like cheating, and in fact it is, unless I add 7 to the right-hand side. See, if I add 7 to the right-hand side, it's legit. I can do it. So I add 7 to the left, and again, the reason I add 7 to the left is because I want that minus 7 to disappear. So these things cancel out, and all I'm left with on the left is 2x. On the right-hand side, I have negative 3 plus 7. If you think of the number line, if you're at negative 3 and you add 7, that's going to take you to the right all the way to 4. So negative 3 plus 7 is 4. Okay, so I have 2x equals 4. I'm doing good. I got rid of the minus 7 that was attached to x. Now, how do I get rid of this times 2 that's attached to x? How do I get rid of this 2 that's being multiplied to x? Well, again, you have to think opposites. What's the opposite of times? What's the opposite of multiplication? Division. So if I want to make a times 2 disappear, I just have to divide it away. And again, this is kind of feels like cheating. Like, how can you just divide it away? Well, what makes it legit is if I divide the right-hand side by 2 as well. See, now it's not cheating. Now it's just moving marbles around. So if I divide by 2 on the left-hand side, it's going to cancel this 2. And I'm just going to be left with x. And if I divide by 2 on the right-hand side, I get 4 divided by 2 is 2. So that's all linear equations are. See, you start off with an x somewhere in your equation, then there's a bunch of stuff attached to it. And what you do is you start undoing the things attached to it. We undid the minus 7 by adding 7. We undid the times 2 by dividing by 2. And the thing that makes this legal is if you do it to both sides. Okay, so that's what's happening when you solve a linear equation.